Good morning students, I am Markialo. Today we will study about Polynomial chapter 2 mathematics of class 10. Today our topic is relationship between zeros and coefficients. Relationship between zeros and coefficient of polynomials. First case is linear polynomial. The example of linear polynomial is ax plus b, where a is not equal to 0. This is the general form of linear polynomial. Its degree is 1, so number of zeros will be 1. Now write ax plus b equal to 0. This implies that x equal to minus b by a equal to minus b is the constant term upon a is the coefficient of x. This is the relation between zeros and coefficient. Second condition, in the case of quadratic polynomial, first is linear, second is quadratic. The general form of quadratic polynomial is ax square plus bx plus c, where a is not equal to 0. Here the degree is 2, so the maximum zeros will be 2. Let alpha and beta be the two zeros of this polynomial. Let us suppose let alpha and beta be the two zeros of polynomial ax square plus bx plus c. Then we can write a, take a as common. You can write x square plus b by a x plus c by a. When you take common from this polynomial, then you can write like this. This will be equal to a. Here we suppose that alpha and beta are two zeros, so the polynomial will be x minus alpha and x minus beta. Now simplify this. You write ax square plus b by a x plus c by a, and here multiply these two. You will get x square minus alpha plus beta x plus alpha beta. On comparison, we will get the constant, the coefficient of x is b by a and coefficient of x is minus alpha plus beta. So you can write alpha plus beta equal to minus b by a. This implies sum of zeros equal to minus b is the coefficient of x. So minus coefficient of x upon a is the coefficient of x square. A is the coefficient of x square. So you will write coefficient of this is the relation between the sum of zeros, and on comparison here constant term is alpha beta and here constant term is c by a. So alpha beta equal to c by a. This implies that product of zeros equal to c. What is c? C is the constant term upon a. A is the coefficient of x square. Coefficient of x square. This is the relation between zeros and coefficients. Third equation is a third polynomial is cubic polynomial. Cubic polynomial. The general form of cubic polynomial is ax cube plus bx square cx plus d, where a is not equal to 0 and maximum zeros equal to 3, because degree of this polynomial is 3. So let us suppose that alpha beta gamma be the three zeros of this polynomial, that alpha, beta and gamma are three zeros of the polynomial ax cube plus bx square plus cx plus d. So take a as common. You will write x cube plus b by a x square plus c by a x plus d by a. This will be equal to a. Here alpha, beta and gamma are three zeros. So the polynomial becomes x minus alpha, x minus beta, x minus gamma. Now simplify this. You will get a x cube plus b by a x squared plus c by a x plus d by a equal to a. When you multiply this term, you will get x cube minus alpha plus beta plus gamma x square plus alpha beta plus beta gamma plus gamma alpha x minus alpha beta gamma. So on comparison, we will get alpha plus beta plus gamma, coefficient of x square, here coefficient of x square b by a. So alpha plus beta plus gamma equal to minus b by a, and the coefficient of x is this and coefficient of x is this. So alpha plus beta plus alpha into beta plus beta gamma plus gamma alpha equal to c by a, and constant term is this and constant term is this. Alpha beta gamma equal to d upon a. Here minus, so you will get minus d upon a. The sum of zeros will be minus b upon a, and sum of the product of two zeros equal to c upon a, and product of three zeros equal to minus d upon a. Similarly, you can solve for by quadratic polynomial and so on. Now today we will learn about the exercise of polynomial. So let's start here. We already learned about graph of polynomial. So exercise 2.1, question number 1, the graph of y equal to px are given. Figure 2.10 below. For some polynomial px, find the number of zeros of px in each case. The number of zeros when the graph of polynomial cuts the x-axis at how many points, that will be the zeros. Here this graph doesn't cut x-axis, so in this case there will be no zeros. This graph cut at one point on the x-axis, the number of zero is 1, and this graph cut x-axis at 1, 2, 3 points. Then for this polynomial the number of zeros will be 1, 2, 3, and this graph cut x-axis at 1, 2 points, so that number of zeros will be 2, and this graph cut x-axis at 1, 2, 3 and 4 points, so the number of zeros will be 4, and for this graph the number of zeros will be 1, 2, 3, because this graph cut x-axis at 3 points, that is 1, 2, 3. So there for this graph number of zeros equal to 3. This is exercise 2.1. Now we will study about exercise 2.2. Exercise 2.2 is this. First question is, find the zeros of the following quadratic polynomial and verify the relationship between the zeros and the coefficient. First we will find the zeros and then verify the relationship. So let us find the zeros of this polynomial. First question is, here first question is x square. First question is x square minus 2x minus 8. Question 1, part first. X square minus 2x minus 8. Find the zeros. So we will factorize this. The factor of 8 equal to 1, 8 is 8, 2 4 ja 8. So 4 minus 2 equal to 2. So you will take this value. You will write this is equal to x square minus 4x plus 2x minus 8. Here we will write minus 2x in the form minus 4x plus 2x minus 4x plus 2x. This becomes minus 2x. So now take common this x minus 4, and here plus 2 x minus 4. So it becomes x minus 4 and x plus 2. If x minus 4 equal to 0, then x equal to 4, and if x plus 2 equal to 0, then x equal to minus 2. So there will be zeros equal to 4 and minus 2. This is the zeros. So our question is find the zeros. The zeros are 4 and minus 2. And secondly, verify the relationship. Now verify. Then sum of zeros equal to 4 plus minus 2. Yani this is alpha and this is beta. This becomes equal to 2. And using formula, sum of zeros equal to alpha plus beta equal to minus b upon a, and this equation minus b means coefficient of x upon coefficient of x square. The coefficient of x is here, coefficient of x is this is equal to minus, and coefficient of x is minus 2 upon coefficient of x square. Coefficient of x square is 1 upon 1 equal to 2 upon 1 equal to 2. So this is 2 and this is 2. It means sum of zeros equal to minus coefficient of x upon coefficient of x square. This is first part verified. And second, product of zeros equal to 4 and minus 2, 4 into minus 2. This becomes minus 8. Now using formula, product of zeros equal to c upon a. C means constant term upon coefficient of x square. So constant term is here minus 8. This is minus 8, and coefficient of x square is 1. This is 1 equal to minus 8. So here minus 8 and here minus 8. So here we will get the product of zeros equal to coefficient of constant term upon coefficient of x square. This is verified the product of 0. In this way we can verify the relationship between the sum of zeros and product of zeros. Similarly, you can solve all parts. And second question is, find the quadratic polynomial each with the given numbers as the sum and product of its zeros are this. So let us solve this polynomial. Question number 2, part first. Find the quadratic polynomial whose sum and product of zeros are this. It means sum of zeros alpha plus beta equal to 1 by 4 and product of zeros alpha beta equal to minus 1. This is given. Sum of zeros is 1 by 4 and product of 0 is minus 1. So quadratic polynomial we have a relationship for quadratic polynomial is x square minus alpha plus beta x plus alpha beta. This is the quadratic polynomial. For any constant k, here k is any constant, this is true for all constant. So now we will take this condition. So polynomial becomes x square minus alpha plus beta is 1 by 4 x plus alpha beta is minus 1. So this becomes x square minus x by 4 minus 1. This is quadratic polynomial, or after simplification you can write in this way. Take LCM as 4, this becomes 4x square minus 4 1 minus x, this becomes minus 4 and equate it equal to 0, and then it becomes 4x square minus x minus 4, so that required polynomial is x square minus x minus 4. This is the answer. So similarly you can solve all these parts. Thank you very much.